This videotape will show the process for cutting internal threads with a tool known as a tap and cutting external threads by means of a cutting tool known as a die. After viewing this videotape, you will be able to list some of the safety precautions which should be used in the machine shop, identify some of the safety precautions that should be used in tap and die threading on the engine lathe, and write down the steps to follow in the process of cutting internal threads using a tap and external threads using a die. When working in the machine shop, always wear safety glasses. Keep sleeves rolled up above the elbows and remove all jewelry. This videotape will show you how to cut internal threads with a tap and external threads with a die on the lathe. Tap threads are not as accurate as chasing threads with a single point tool, but the time required in the manufacture of the thread is considerably less. This demonstration will show how to tap a 1/4 20 thread in a workpiece. Before tapping threads on the lathe, a hole must be drilled using the correct size tap drill. The correct size drill can be determined by referring to the machinery's handbook or a tap drill chart put out by various manufacturers. The machinery's handbook shows a number 7 tap drill is used for a 1/4 20 tap. Face the end of the workpiece square before drilling. After facing, place a drill chuck in the tailstock and mount a center drill in the drill chuck. Select the proper spindle RPM for center drilling. Lubricate and center drill the workpiece. Remove the center drill and replace it with a lead drill, which must be smaller than the tap drill. Reduce the RPM, lubricate, and drill the lead hole. This drilling procedure will ensure an accurate diameter when the number 7 tap drill is used to drill the hole before tapping. Place the number 7 tap drill in the drill chuck, lubricate, and tap drill the hole. The final preparation of the hole is to chamfer the opening to a diameter equal to the major diameter of the thread. This can be done by using the tool bit from the facing operation or a countersink mounted in the drill chuck. The purpose of chamfering is to assure a more accurate alignment and prevent the tap from making a large burr at the start of the thread. Remove the drill chuck from the tailstock and replace it with a dead center. Lock the spindle in a low RPM to prevent it from turning. For this demonstration, select the proper size T-handle tap wrench for a 1/4 20 tap. Place the tap in the tap wrench, and with the tap positioned in the hole, bring the tailstock and dead center into contact with the end of the tap wrench. Small taps may not have a center hole and are normally used with a T-handle tap wrench, since it is equipped with a center hole to give alignment. Extend the tailstock spindle slightly by cranking the wheel, and then lock the tailstock in place. Provide clearance for the tap wrench over the ways of the lathe by moving the compound toward the headstock. Apply a small amount of lubricating oil on the tap. Begin the tapping operation by turning the tap wrench in a clockwise direction while applying pressure to the tailstock spindle with the hand wheel. After 1 or 2 turns into the hole, reverse the tap approximately a half turn. This breaks the chip and prevents a buildup of chips which could break the tap. Continue turning the tap into the hole, occasionally reversing to break the chips until you have tapped the hole to the desired depth. A taper or plug tap may be used for tapping a hole all the way through a workpiece. For tapping a blind hole, that is one which does not go all the way through the workpiece, you should drill the tap hole slightly deeper than the length of thread you desire. Then do the initial tapping with a plug tap. Complete the operation with a bottoming tap. When you have tapped to the desired depth, move the tailstock back and remove the tap by turning the tap wrench in the opposite direction. Another way to tap on the engine lathe is by holding the tap rigid and turning the workpiece held in the lathe chuck. This demonstration will show the procedure to tap a 3/8 16 hole. Use the same hole preparation procedure as before, except that for a 3/8 16 tapped hole, use a 5/16 tap drill. Move the gear shift to make sure the spindle is in neutral. With the workpiece held in the chuck, place the end of the tap into the tap drilled hole. Move the compound to a position where the tap wrench can rest against it. Slide the tailstock forward until the dead center is seated in the center hole on the tap, and then lock the tailstock in position. Lubricate the workpiece and turn the lathe chuck, either by hand or by using a chuck wrench for added leverage. Apply a steady clockwise pressure on the tailstock hand wheel to produce a slight pressure on the tap and to keep it aligned in the hole. After you have cut 2 or 3 threads, back the tap to break the chip. Continue cutting threads and reversing the workpiece until the threads have been tapped to the desired depth. Move the tailstock away from the tap and run the carriage toward the tailstock to make clearance for the tap wrench. Back the tap out of the hole by hand. This method will also give you a thread which is tapped true to the axis of the work. Tapping with power on the lathe requires experience and practice before it is attempted on a job. Use a spiral point tap with a low spindle RPM. The lathe must have a reversing lever to tap using power. Power tapping is not recommended for shallow blind holes. For power tapping, follow the same preliminary steps for center drilling and tap drilling. Then place the tap in the hole and support the tap and tap wrench with the dead center in the tailstock. The tap handle is placed against the compound to prevent it from turning. In this operation, set the spindle speed to a low RPM, approximately 10 to 30 RPMs, and be sure the tailstock is not clamped to the ways. Engage the clutch and allow the tap to be pulled into the work. Keep lubricating the tap and advancing the tailstock to give support and alignment to the tap. After approximately 1/2 inch of threads have been tapped, reverse the lathe to clean away the chips. Then continue tapping and reversing until the operation is completed. When the workpiece has been tapped to the desired length, reverse the lathe and apply a slight pressure to the tailstock to keep the center supporting the tap as it is back from the hole. Small taps may be mounted in a drill chuck instead of using a tap wrench. Although tapping with power is a very time-saving method, you need to be extremely cautious to prevent breakage of the tap. A tool called a die is used for cutting external threads. Threading dies are made in 2 varieties, the solid die and the adjustable split die. The adjustable die is equipped with a small set screw which expands or contracts the die to produce various thread fits. Before die threading, the surface to be threaded must be turned to the required diameter. This demonstration will show the procedure for cutting a 1/2 13 thread on a workpiece. The major diameter of the thread will be 1/2 inch, and there will be 13 threads to the inch. Mount the workpiece in the lathe chuck using a straight turning procedure. And turn the outside diameter to 1/2 inch. Chamfer the end of the workpiece so the die and the mating nut can be started more easily. Next, select the proper die and die stock and secure the die in the stock. For this demonstration, we are using an adjustable die. To begin threading, place the die and die stock against the chamfered end of the workpiece and bring the tailstock spindle against the end of the die. Set the spindle RPM to a very low reading, not more than 10 to 30 RPMs. Brace the handle of the die stock against the carriage or compound to prevent it from turning. Apply a generous supply of lubricant where the die will begin cutting and engage the clutch to start the lathe. Exert a constant pressure on the die by following it with the tailstock spindle. As soon as the die is securely started, discontinue the tailstock pressure. Since an adjustable die is being used, a trial cut of a few threads is made, and then the threads are checked with the mating part. A thread ring gauge may also be used to check the threads for size. Make any necessary adjustments so the die will cut the proper size. You should keep adding lubricant to the workpiece at the threading point and allow the die to feed onto the workpiece. The work must be reversed occasionally to break the chip. Continue threading until the work is cut to the required length. Reverse the lathe spindle and let the die feed off the work. If the lathe does not have a reversing lever, place the spindle in neutral and turn the work backward by hand. It will be necessary for you to hold the die to prevent it from turning. Threads that are cut with a die are not the most accurate threads. Another way to produce threads is using the thread chasing nut method. In this method, use a slightly open die to rough the threads. Then follow the die operation with a thread chasing nut, which has been precision ground to give the proper thread size. Never use a thread chasing nut on a straight workpiece that has not been rough threaded, as it will ruin the nut. Never use the thread chasing nut to remove more than 5 to 10 thousandths from the thread. Use plenty of lubricant on the thread chasing nut. The thread chasing nut is the same as a solid die and will give only one fit. It can be used for cleaning and reshaping existing threads that have been burred or damaged. Do not use power on the lathe to cut smaller diameter threads with a die. The high torque produced by the cutting of the threads can bend or twist the rod on which the threads are being cut. These threads should be cut by hand. In review, you have seen some of the safety precautions to be observed for tapping and die threading on the lathe. You have seen the steps to follow when making internal threads on a workpiece using a tap, and the steps to follow when cutting external threads on a workpiece using a die. The knowledge and efficient use of the tapping and die threading operation on the lathe will make you a better machinist.